access network. Access network. So access to where, right? Access to the core network. So after the core network in this part, actually we have many routines, right? We have many routines. So the last week we studied the VLAN, right? Yeah, VLAN. So up on the VLAN, so that is the routine. It's the routine protocol. It's routine. So this is why we introduce the routine. Okay, so in the routine protocols, I will introduce the routine overview. Some we call is the direct route. Some we call is the static route. And then the most important is the dynamic route. Dynamic route. This one is we use a lot in the commercial system. Dynamic route. We don't suggest the OLT, although our OLT have the route function. This one has the root function, but we don't suggest to configure the routine protocol in the OLT because this one will occupy the OLT's capacity. We occupy its CPU. It occupy its memory. Memory. Yeah, this one. Because the router, okay, the router design, the hardware design is based is not based on the CPU. Okay, when he transport the packet, okay, the packet, when he transport the packet, the design is not based on the CPU. It's based on the hardware. He will directly transmission the packet by the hardware by the port. So this is why we suggest if we need to configure some routine, we suggest configure in the router. It's not configured in the OLT. Although our OLT also supports some route protocol, but we don't suggest that because the different specific yeah the equipment the network equipment it has its own character, right? Okay, so let's see what is the routine. So first, we are not only one router in the network. We are more than one router. So which path is the best from the A to B? So this is we so-called the routine. Maybe you think the less router go to the destination is the better, but exactly it's not like that. It's not like that. For example, this router maybe it's just 100 megabyte for the interface, just 100, and this one even less, It's just 10 megabit, right? Yeah. But all these all the others router they provide 1 giga. Maybe E1 is large, right? Maybe 10 giga, maybe 100 giga. So actually, so the path maybe even this one it pass 3 router. So this road is still better than the than this road because the bandwidth is different. So this is we so-called the routine. So-called the routine. So the routine is in the layer 3 in the module. Okay, in the layer 3. So in the layer 3 means it using the IP address, right? It use the IP to identify where it's going to, where's the package should send into. So the MAC, address. In the host A, we have MAC address. So the MAC address will only remain in the switch. Okay, this is the MAC A, right? So after we go to this router, so the MAC it will convert, it will change to this interface MAC. For example, this one, let's say this one is MAC 1, okay, MAC 1. So the MAC A, it will remain in the switch. So if you remember, last week, when I introduced the switch, and I introduced the VLAN, we said the switch, it has a table. It has a table, right? So what is inside in the table? Do you remember that? Yeah, we have a MAC address, right? We have a MAC address. We have interface. We have interface. We have interface port, okay? Interface port number. The MAC one, interface one, right? Yeah. And then it's the IP address, right? So in the switch, we have such a table, okay? Yeah. So in the router, so it also have the table. It also have a table. So in this table, actually, it's just, almost like that, but he will have but the router actually he don't care the MAC. The MAC address actually he don't care. Okay, because it's a layer 3. Layer 3, he don't care the MAC. So the MAC, for example, the MAC A only remain in the switch. After it go out this area, something like it go out of the VLAN, it go outside the VLAN. This MAC will not go to the next VLAN. Okay, it will not go to the next VLAN. The MAC. Okay, here. So in the router, he don't care the MAC. He will remark the IP address. And then is the port. Is the port. And then is the we so called the less hot. Less hot or less hot. This one, less hot. Okay. So for example, the IP address 100.116. Okay. Yeah, this one. So it comes from the interface 1. Something like in the port 1. So the next hop, it depends on the destination. Here also have the destination. Okay. Yeah. Oh, actually, it should be like destination first. Destination first. Here, the destination. Destination, and then it's the left hop. Oh, sorry. It doesn't matter. Okay. Yeah. Yeah. So it's the IP first. Okay. So in the table, IP, and then it's the port number. And then it's the destination. Okay. Destination, and then it's the left hop. So the IP is from, for example, the IP. The original IP is 191, this one, okay, 192, and the destination IP is like this one, okay, it's like this one. So he come to here, and then he will tell him where the last hop to go into. So the last hop, could be the IP, the actual could be the IP, or could it be the port? For example, the IP is port 2. This one is port 2. So the IP he gone to here, he want to go to this one, and then inside this table, this router, he will check this table, and then to tell this packet, he should go to here. Okay, he should go out from here. It's like this. So this is the routine table. Okay, we call so in the switch, we have a switch table. Okay, we have switch table. In the router, we have a router table. Okay, so this is the principle, how the user to check the address, right? Yeah. This one is also like a zip, right? Everything is that just like a zip, like zip, because he need to check the mapping. He check the mapping. Okay, so this is the root principle. So here is some kind of the routine. We have a statistic. Statistics means we do it manually. we do it manually. Here we have one route. Here is we have another router. Okay, we have two router here. So I manually configure one way to go. Okay, yeah. For example, 192 series, and then here we go to 117 series. Okay, yeah. So I will configure all this packet. If the destination is 172, and then I will go from the port 1, and the less hot. Here we have a gateway here. Here we have a gateway. For example, usually we set the gateway is a 192, 168. For example, the gateway is be like this. Okay, yeah. So all the IP from here. So here we have some PC. Okay, we have some PC, PC1, PC2. Okay. All these PC, they get the IP range is 192.168, right? Like that. So if this PC he wanted to go to the 172, maybe it's a web server, maybe it's the internet. Okay. So inside this router, he will let them to go out from this gateway. Okay, let's go out. And to the next, to the next hop, and then he will tell here. Okay, here. Also, this one, we also have address to this one. Okay, yeah, it's also is the same. Okay, yeah. So he will also tell the let's hop. So it's this gateway. Okay, it's go to here. So this is one way to go. And then in the router 2, and then he will tell if all this address, all this this one maybe is the PC, maybe a server, okay, maybe a website. So all this server, all this IP, if he need to send back, right? He need to send back the packet. And then where to go? Where to go is to go to the router 1. The IP address is this one. Okay, and then he will tell all this packet. The IP you should go to the gateway. Go from the gateway, and then the next hop is this one. So this one we configure it manually. So we call it the statistic. Okay, yeah. So compare the statistic. We have some default route. We also have a default route. So that means because maybe here we have another port. Okay, another port, and then we go to another router. For example, this one is 10.x. Okay, yeah, in this one. Okay, so we have a two, and then we have a two route. And one route is go to the router 1, another one is go to the router 3. Okay, another IP range. So in here, you also have another gateway. Okay, so for example, maybe 192 maybe it's a 253. Okay, maybe this one. So here and then we have a two gateway. Okay, gateway 1, gateway 2. So so we can say one of them is the priority. Is the higher priority. So in the higher priority, we so-called is the default. So something like maybe he wanted to go to this IP, this PC, maybe he wanted to go to something 11.11.11.11. So this range is 172. This range is 10. There's no range for the 11. So in this case, he will go to the default, and then he will go to the here, go to the default 172, 192. This one, this is we so-called the default route. After he go to here, actually, in the router 2, maybe he connect to the router 3, router 4. So after the router 4, maybe the 11 range is under the router 4. So this is this one so this is the router. He will check, and then he will send the package more router. So this one it means if this one is if the destination is not inside the router one, and then he will go to the default to let the other router to check. So this one we so called the default route statistic default, and then it's the dynamic, So as yes, as the graphic I drawn here, you see we have many users, right? Yeah. When I introduce this one, and I only introduce the two root, and then I introduce another root, and then in some cases we have some more root. So actually the user maybe getting more and more because the services maybe because the network technology maybe it's getting more and more user. So in this case, if every times we need to configure manually, it's not good. It's not good for the maintenance. It's not easy. Okay. Yeah. So in this case, the scientists they developed the dynamic route. Dynamic route. It can automatically realize here is a new we have a new user coming. Okay, and then he will automatically to making to update the user table. Okay, he will the user table. Okay, so the user table is statistic. All right, the dynamic, that means he can update the user table automatically. So this is so-called the dynamic. Okay, yeah. So in the dynamic route, we have some typical protocol. For example, the BGP, the OSPF, right? The WIP. This one is so typical. And this one and those topical protocol, some we call is the IGP, some we call is the EGP. IGP means the internal, okay, the internal route. Or those, even those we have a lot of the router, okay, even though we have a lot of the router, but all these router is belong to one area, or maybe it just belong to the same company, right? It become to the one same area, same city, something like same city, some company. Okay, yeah. So here we also have another a lot of the router. Okay, so this one is in the we call it the core networks, right? In the core network, in the bare network. So from here to here, so this one we call is the internal. We still call it the internal interior. Okay, interior gateway protocol. Okay, so after this one, it will go to the another area. So this one we call is the in the protocol, we call this one is the EGP border. Okay, sorry, I think this one is okay. I think this one is a typo, a BGP. Okay, or is external. Okay, yeah, BGP, border gateway protocol. Yeah, this one is a typo. Okay, yeah. So some protocol is based on the links status, and some user protocol is based on the director. Yeah. So here, yeah, actually I already introduced this one, right? Yeah. So we have we have the let's hop concept, and then we have the subnet, we have the mask, and then the let's hop. Okay, the let's hop. So the let's hop, it can be the interface. It can also be the IP address. Okay, this one is a relative. We can set. Usually, we will set as the IP address. We will not set the interface. It can automatically to update the interface information in the user table. So usually we manually set the IP address. So why we not set the interface? Because in the router, okay, sometimes we find this hardware, this port, this interface has some problem, and then we will change, right? Yeah, and then we will change the cable to another port. Okay, so if we manually to set the interface, it's not good. It's not good to for the maintenance. We need to change the cable, right? Yeah, so we usually we set the let's hot by the IP address because after we change the cable to the port 2, the interface will not change. So this one, so this is the IP table. Yeah, the source IP and destination IP. Okay, so here we see in the OLT website, we have some U10 U10 protocol. We support the BGP, we support the ISIS, we support the statistic, right? Yeah, we support the statistic, we support the OSPF. A lot of the protocol we support, but we don't suggest to configure that. In this case, let me see. Let me show you. See. Yes, it's in the configuration. In the configuration, where is the here the root? Okay. So we see we also have a FB. This one I need to check because this one I think is the new function. Okay, yeah. Okay, so we have see the statistic root. Okay, statistic. We configure it manually, and then we have a root here. Okay, by default, we can see the let's hop is is root interface. Okay, so here we have we can see this one. This IP address is the PC itself IP address. We so-called is the loop. Okay. Yeah. So it doesn't matter the our PC. Okay. It doesn't matter our PC or our or some router. This IP address is all is reserved. Something like his own name, his own IP address. So this one, if some packet, something like the packet go in, and then he don't know where to send this packet. He don't know. He don't know where to send this packet, and then he will all go to the all go to this IP address. Okay, to this something like it, discuss it, discuss, ignore it. Okay, so this one we so called is the reserves IP. And here is the FYP. What does this mean? I need to check, and then I come to you. Okay, so this one is so-called the U10 fundamental. And then now we go to the direct route. Direct route. So the direct U10 it means after the PC or after other equipment connect to the okay something like yeah maybe yeah direct to connect to here okay because this graphic is drawing one more layer just so the interface connect to the router. So this one we call is the directly connected. After direct connecting, and then he will automatically generate router information. For example, giga 0, okay, giga 0. And then the destination is to one is to here, okay. The destination is to here, okay. Yeah. So this one. It's so-called the destination. It's something like also is the source, right? Something also is the source is coming from. But for the router, we standing in the router, okay? We standing in the router. From the router's view, this one is also is the destination. right? Yeah, we stand on here, okay, and then we from the uter, we are the uter, okay. For the uter, so this one is not the source, it's not coming from, right? It also is the destination, because maybe we behavior to stand on the PC, and then we think this one is going out. This one, the uter is the destination. But now we are talking about the uter protocol. So we stand in the uter. So inside the uter, all this one is the destination. Okay. Yeah. So here, why this one is so called the destination. So this one is directly to connected. So we call it the direct route. Direct route. The direct route, it has the highest priority. We can see this one. So let's see some keyword automatically, okay? Automatically generate, and that is the highest, highest. So this will be so-called the directed. Okay, so here we have some, here we have some command in our OLT. We can use the show IP route and then to check the util information. Okay, actually it's the same, right? Here we can use the we can use the command, or we just go to the website and then go to the root and then root. Okay, we can get the same information actually. Okay, static root. This one actually I already introduced, right? Okay, so to remind you, the static root, we have to configure two times. Two times. One way to go. Okay, another way we say is to back. So we configure in the router one where to go. Okay, where to go. Okay. So in the router two, we also configure where to go. But for the router one, it means that this one is to go, and then this one is to back. Oh, sorry. This one, we Chinese engineer, we would like to say like that, okay? We would like to say you configure the go router, and then you need to configure the back router, router in the router B, okay? Yeah. So let me see any. Okay, it seems I get some message. Okay, yeah. Okay, yeah. So this is a static routine. This one is just telling how to configure. Here, IP use statistic. This one is the original IP, the source. Okay, this one is the source IP. This one is the source IP. Okay, the source IP, and the IP range, and then where to go. Let's go to. So this one is the less hot. Let's go to here. Okay, go to here. Okay, and this one is for the comeback, right? This one is for the comeback. And the mask, the lab mask, we can be presented in the dot. We call this one is the dot decimal. Okay, we call this one is dot decimal. Dot decimal. Okay, dot decimal. Okay, and this one we can represent directly in the 32 in one number, right? You could just in this one in just one number, 24. Okay. So how to convert this number to the dot decimal? Do I need to make some introduce? Yeah. Okay. So let's see. So we have. Okay, so this one, we have a times of 1, right? So from the binary, okay, so from the binary, convert to the decimal, because the binary is the machine, to understand, right? It's for the machine to understand, and we are human, when we are human, So for our humans, we more understand to the decimal. So if you convert it, so this one is all its full is 11. So it equal to 255. Okay, this one. We say in the binary 1, 0, and 1, and then is 10. Okay, 10 is equals to 2, right? Equals to 2, and then we plus 1, so that this is the 3. Okay, this is the 3, and then 1, 1, 0, because we add 1 and then go this one. It became is the sorry, this one. This one is the 4, right? Yeah. So blah blah blah. So actually we have the formula 2n. Again is the 2n. We have this formula. So anyway, a times of the 1 is equal to this one. Okay. So the 24 means 3. 3 multiplies the 8, right? So this one is the 24. It's 24. 1. Okay. Yeah. Okay. So here, statistic as one way to go, one way to come. One way to come. So if maybe you will confuse. This IP address. Okay. This IP address is in the router 2. It's not in the router 1. So here, so this part. So this part is from the is for the router 1, okay, the source, and the destination is in the router 2. This one, of course, is easy to understand. Something like you want to send some mail, right? Yeah, send some mail. So this one, I'm in China, okay? And you are in Mexico, right? You are in Mexico or Venezuela, right? Yeah. So when I send this mail, of course, the address I'm writing in the Mexico address, right? Yeah. So this one. So this is so-called statistic. We configure manually. For the routine, if you have more question, and then you can ask me after the training, no problem. Okay, yeah, we can discuss. No problem. Okay, so here, this one is in the website. Yeah, in the website, we can set the default. We can set the statistic root by default. Set them from here. Okay, so the dynamic route, we have the VIP, we have the OSPF. Actually, the VIP so far is not so popular, not so popular, but it's still typical. So this is why I need to introduce, because the VIP is the typical distance vector. Okay, it's this one. Destination vector, distance vector. So something like he will calculate by the hop count. For example, from here, okay, from here to here we have a PC. PC here. This one we can assign PC. Okay, yeah. The hop count, it means he will calculate how many users it has. It need to jump. For example, he jumped to here. Okay, this one is directly. So yeah, so this one he think this this way is better. Okay, this one is the better. So we choose this one. And this one because it's one more user here. He need to jump to 2 user, right? Yeah, 1 and 2. And then he think this one is not good. But as I said in the beginning, because sometimes this one is just 10 gigabit, and actually this one we have a 1 gigabit. This one we have a 1 gigabit. So actually this one is more better. Okay, yeah, this one is from the bandwidth. And we also can thinking about maybe this user is the old module, right? maybe it's old module. So in this one, in this case, we also consider this one is better. Okay. Yeah. So this is why the VIP, the routine information protocol, why this VIP is not so popular so far. So currently it's not so popular. popular. But the VIP is still for the simple configuration. The small network we still can use. Actually, even in the small network, we would like to use the OSPF. Okay, the open shortest protocol. This one. Even in the small network. Okay, so here, when we're talking about the user protocol, it always, okay, it doesn't matter. It doesn't matter what type of the protocol. The key, okay, the key technology is how they switch the user table, okay, how they can transmit, switch the table. For example, the table in this router, because it has his a knowledge about this one. Okay, for example, this one is a big network. Okay, behind the user A, it has more user information here. Okay, more user information. So now blah blah blah. Okay, so and then we have a PC. Okay, we have a PC in the Mexico. Okay, we have PC in the Mexico, and then here also we have a lot of the user. Okay, a lot of the user, and this one is in Bolivia. Okay, and then this one we also have another many user, and then we have a PC in Venezuela. Okay, so the user A and the user C. Okay, because the some PC he wanted to go to Venezuela like this. So as we see, this router, okay, this router, they are not directly connected to here, right? They don't. Okay, all these areas, the router, they are not connected to the router C. So how the router C can understand my PC, the destination is going to the router A. So the router A, he need to tell the router C what information I have. Okay, what information I have. So he need to tell the router C. It's the same. The router C also have to tell him what information I have. So they are switching the information. Okay. So this is the router table. The information is the router table. So the router protocol is to how the router to change to synchronize, right? To synchronize the router information. So this part, right? The user C, he get the information by his own, and then he will tell the user A. The user A, he also will send his own information to user C. So this will be so-called a synchronize, right? Yeah, the synchronize the user table information. So all the protocol is based on this the user table transmit. Okay, this one. So as I said, this one because it has many user behind this one. Okay. So all the user information, something like the summary, summarize. Okay. Yeah. We call it the summarize routine. Summarize routine. So for example, here I said this one is in Mexico, right? In Mexico. So I have Mexico City. Okay, your capital is a Mexico City, doesn't it? And then you have another city. Okay, city A, city B, city A, city B. So in here, in Venezuela, okay, you also have a city A, you also have okay, also city AA, city BB, okay, like this, okay, yeah. So so in the user A, he don't need to tell the user C the every detail of the city it has own, okay, every city it has own, it doesn't tell to him. He just tell to him everything you go to Mexico, you can come to me, okay? And the user also say every message you want to go to the Venezuela, you come to me, okay? Yeah. So this is so-called the summary util table, okay? Util information, summary util, okay? So let's get some detail. For example, the Mexico City, he get the address 126, okay, .1.1, okay, this one. So in the city B, it has the IP range is 192.168, 2, okay, 2 dot, 2 dot X, okay. This one is 24 sublet. And the CTP also, it has the 1.133, okay? This one is the 3, okay? So the user A, so how the user A to tell the user C? So in this case, how? So in the IP address, how he can represent it, the summary information. So the summary information is the user A tell everything. You go to 192 this one is a 16, okay, 16 sublet, okay. So everything you go to 192.168, you come to me, okay. So this range is a bigger range than those than those 24 sublet. So this is so-called the summarize. It use the net mask. We use the net mask to summarize some information. So this one, I I hope this introduce can to help us to understand. Yeah. So the user A and the user C, they synchronize the user table is not with the detail actually. And of course, you think maybe some IP range is special, and then you can also put in the user table. But in this case, the table will be getting huge, right? It became the huge. Since the table is huge, it will take time to synchronize, right? Yeah. So yeah. So this is the summarized routine, in routine table. And here we have some character about the whip. We have that it has the maximum allowed number. We can see here the maximum allowed number, the hops is 15. So that means behind this one, the router information cannot large than 15, right? So this is why this one is used in the small. And it use the UDP and use the some periods updates. Okay, update for what? Update for this table. Okay, yeah. So here, update for what? Update for this routine table. Okay, this one. Anyway, the whip is not a popular routine. So I will go quick. Okay, yeah, this one, yeah, Vietnam. This one, Vietnam. We use the Vietnam to summarize the information. Okay, do we need some break? No, okay. Continue. Let me finish the OSPF and then we take a break. Okay, yeah. The OSPF, this one is the most popular. This one is the most popular. Open shortest pass first. Okay, yeah. So in the OSPF, we so-called is the link status, link status, link status. So what does the link status? So at the beginning, I said some berries, right? Yeah. So we said it's some berries. How about dumplings, right? Yeah. We also dumplings. We also have some others. So all these character all these parameter we so call is a cost. It's a cost. We so call is a matrix. Matrix. So in the OSPF, it based on the link status. Okay. And here we have some IP address multicast. This one is the multicast. Okay, when I introduce the IPTV, when I introduce the multicast, I will also to tell the detail about the classes about the multicast. So in here, we have one is to send, another one is for the listen. What does this mean? What does this mean? So in the OSPF, we have backbone area. Okay, we have backbone area. Important. Okay, center. This one is in the center. Okay, it's in the center. Okay, yeah. So in here, we have so this one is the main router. Okay, the main router. So for the main router, he will listen. He will listen all the sub areas router the information. So yeah, so in just last set, in last slide, I said the all the Uton protocol is how they symmetries, right? Symmetry the Uton the Uton table, right? Yeah, the Uton table, right? Yeah. So the router three, we need to tell he need to tell the tell this guy tell the master what is information it has. Okay. Also do the router four. He will need to tell the router one what information it has. The router table, right? So where to send? Where to send? So all those router 3, 4, 2, they all send to this IP address. Okay. 224 dot o dot o dot 5. Okay, they all send to this IP address. Okay, and yeah, this one is something like a window, right? It's just like something like a window. All those sub router, he will send the information to here, and this one is the router one to get the information from. And sometimes the router one, he also wanted to understand, he wanted to ask by the router one. So ask to who? He cannot ask one by one. Okay, so he just go to the this address to listen. Okay, yeah. So from this graphic, we can see we have a backbone area, and then we have sub area. This one, area 1, area 2. Okay, yeah. So in this area, we can have more router. Okay, yeah. So we also can see here, it's not directly connected, right? Yeah, everything is go to the router 3. So in this router 3, in the OSPF, we call this router 3 is ABR, area border router. We call this one is ABR. Actually, the OSPF, the principle may be more complex than the RIP. So yeah, so here we have ABR, and then we have ASBR. This one that means this router is going to the internet. Okay, here is something like yeah. This one is BGP, right? Yeah, as we see. at the beginning, when I said the protocol, we have a border gateway protocol. Okay, so all this one is the IGP, the internal gateway protocol. So this one still remain in one area, and this one is already going to the WAN, the internet. So in this one, we call this one is the ASPR. The utility has a different name. And here we have say this one, the backbone. This router is more important, right? So we need to make some backup. So this one is the master. This one not. This one is the master. And this one is the backup. So in this case, we call this one is the DR, and this one is the DBR. DR and the DBR. Yeah, see. Okay. Wait a minute. Oh, it doesn't. Okay, so it doesn't introduce the DR and the BDR in here. So I just tell you. I tell you from here. Okay. DR and the BDR. Okay. This one is the packet. Okay, it's another concept. For the OSPF, we have another concept is the label. The label. Okay. So what is the label? Two router. Okay, two router. So this will be so-called label. So the table. So the router table. They will sync. They will symmetry. They will symmetry the information between the two router, between the label. So first they build the label first, and then they switch the transmit the router table information. So here we have a five. Actually, it's a 5 steps. 5 steps. That means and then each step is mentions each status each time. We have a hello. We have a database. We have a LSR. LSR LSU. It's update request. Why this one? So this is the 5 times the packet to establish the neighborhood. Okay, yeah, it's something like the TCP, right? 4 times, 3 times handshake, 3 times handshake, and this one we have 5 times, 5 times handshake like that. But it's not that very simple. It's this it has the database, right? It has database description. This one is the detail how they can establish. So we have 5 times this one. This one is the packet, okay? This one is the 5 times of the packet. And this one is the state here, status. So we have a down state. So this one is the initial status. And then down, and then we go to the initial. Say hello. Okay, say hello. Say hola. Say hola. And then he will go to the two-way state. And then the DR selection. Election. So what is the DR election? The DR, as I said, in the backbone, right? In the backbone area, I have a 2 router. Okay, one is the master. Another one is the standby. The master one we call is the directory root, the direct backup root, DBR, DR, BDR. So in this case, which one is better to be the master? So they need to so all this router, they need to select. They want to know which one is better. Why? Which one is better? So we so-called so they make some root, with some vote, something like this to elect it. Which one is the better? So actually, in the protocol, actually, it's not those it's not those user to vote. Okay, we based on some parameter. For example, the ID, the user ID to elect it. We can elect it by the user ID. We can elect it by the let's see, it's the interface IP like this. Okay, to select which one is master, select which one is the standby one. And then we go to the extra status and then exchange the status, exchange, and then loading, and then full state. After the neighborhood is established, it's called a full state, and then they can transmit the table, the user table. Okay. Here is not the D is not the direct, is the decided. Backup is the backup decided. It's not direct. DR BDR elections. Okay, so in the OSPF, we have some links. We have some user links. We have a network links. So this we so-called the link status. We have a summary links. Different times. Because the OSPF, we have separate some area from here. Okay, we have some area. There's many type of the area. I will not introduce tips in this presentation. We have some backbone areas. We have a sub area, right? Yeah. We also have a lancer area. Okay. So easy to done for the making the summarize. Actually, is the purpose of this area is to how to make the summarize routine more easy. So in this case, we have a different area. We have a different area, and the different area it have a different type of the link status. Different types. So yeah, this one I don't think I need to introduce deep in here. Okay. Maybe maybe in the level 2, we call is the professional trainings. I will make some more detailed introduce. Yeah, as we see, the OSPF it based on the area. Okay, it based on the area. Yeah, this one is only one area. Here we have 3 area. Okay, 3 area. So the area 1, the router, if he go to the area 2's router, it cannot directly. Okay, yeah, even in the physical, maybe they are in the same city. It cannot go to here directly. Everything you need to go to the area 1. Okay, yeah, like this. So we call the backbone area, and then we call all others area we call is not backbone areas, non backbone areas. Okay, yeah. So here we have some different type of the user. IR, internal user, the backbone user, ABR, area border, right? Yeah. And then ASBR, autonomous system border router. So that means this one, after this one, is already go to the internet or go to another backbone network, right? Yeah. Okay. Yeah. So let me make some summarize. Let me make some summarize for the OSPF. So for the OSPF, so first is we call it the link status. Right, link status. So the link status will include in the bandwidth, including its dumplings or log dumplings. Okay, yeah, including the what else? What else? If we include it, yeah, even is the up and down, right? Of course, it's up and down, right? Up and down. And what else? Up and down, the bandwidth, dumplings or log dumplings, full dumplings, right? And how about the time? How about the time? The link times. What link times we have? We have a zero. We have a zero, right? We have a zero connection, right? We have a fiber, right? We have fiber via PAN, right? Yeah, we also have a fiber, right? Yeah, and then we have the Ethernet cables, right? Cat6, Cat6, Cat5, Cat6, right? Yeah. So all this is we so-called the link status, okay? So the OSPF we based on the link status. So this is the link status. So how to describe some the links between this one? So the packet, the next one, okay, the link status, and then how they can understand each other is the labeled, Okay, this one and this one is the label, right? 1 and 2 is the label. 2 and 3 is the labeled. Okay, yeah. And here, this one is the router 7, right? Router 7. So the router 7 and the router 1 is the label a lot. Okay, they are not the they are not the label, right? They are not the label. So how to understand each other is the label. So we have the different time of the packet, different time of the packet. So we have 5 type of packet, 5 type of packet, and this 5 type of packet, they are used for different 8 type of the status. Okay, 8 type of the link status, 5 times of the packet. So what is the 5 times packet? Hello, right? Hello, and then until the until is the LSR link status routing. They are switching. So 5 times the packet. So the 8 time of the link. So it's the from the down, right? The link status from the down. This one is 8 time of the status. It's done until and then it's the two-way, right? Two ways, and then it's go to the after it's a full way. Okay. After the full ways, and then these two router they understand each other. They are labeled. And the OSPF also based on the area concept. We have an area concept. We have the backbone concepts. We have a long backbone area. So because we have different areas, and then we have different types of the router name. We have a DR decided the master DR, okay, and then we have a BDR the backup decided router. And then we have ASBR, we have BDR, right? BDR border router, ASBR, ABR, okay. And for the ASBR, this means this one actually is going out of the VLAN. So this one after that is the BGP, okay. It's for the BGP. Okay, yeah. So this is the uter, the utin table, the utin introduced. Actually, if I need to introduce the OSPF with the more details, it should take 2 hours. It should take 2 hours. Okay. And here I just made some quick introduce, made a simple introduce. So let's take take a 10 minutes break, and then we go to the Wi-Fi, For the routine presentation, maybe I'm not represent so clear. You can ask me after the training. Okay. If we are the first time to get those knowledge, maybe it takes times. Yeah, it takes times to yeah, to think about that. But anyway, presentation is just the beginning. We can threaten each other more and more after the training. Okay. Okay. So let's test some breaks. Maybe the utility protocol is yeah, the OSPF. Maybe it's a little complex, right? But anyway, this is the routine. After this presentation, I think we can understand what which times, right? Here. Wait a minute. This one. Okay. Yeah. We understand. We understand how the router working, right? It use the router table, right? It use the router table, and what inside the router table? It has the source IP address. It has the destination address, and then it has the last hop, and then it has the last hop, right? This one, we get it from today, right? It's good. Anyway, it's good. And then we know we have a statistic. We have a default. We have a dynamic, and then we have a IGP, right? We have a IGP protocol internal, and then we have a BGP external. Okay, yeah. Here is a of course this one. Oh, of course, this one is a typo, okay? This one is a typo, okay? This one is a BGP, okay? BGP. Oh, no, it's not a hypo, it's a border. It's borders. Okay, I will double check this one. Okay, so we have OSPF. We have OSPF. So since you are the ISP, so maybe you also using the ISIS. So let me make some preparation for this ISS in the future, okay? In the future, maybe I also introduce this one, okay? Okay, so this is for the first hour. Let's take some break. Let's take some break and then we continue. We continue the Wi-Fi. The Wi-Fi is more easy to it's more easy to understand and it's more interesting. Okay, take some break. Take some break. Yeah, if you come back, yes, exactly. Yeah. Mm. Thank you, thank you. Okay, yeah. So we continue. For the Wi-Fi part, actually, I feel very interested when I first time to learn the Wi-Fi fundamental. Um, since we 3 days, right? Today is the first day. So sorry, this one. Okay, so we already get the knowledge about the pump, right? Let's say it's the optic, okay? The optical. We have the optical knowledge, okay? So we have the downstreams wavelengths, right? We have the upstreams wavelengths, and we have the slippers. We have the slippers, right? The slippers knowledge. We have the slitter. We have the attenuation. This one, let's say, is the ODN. Let's say it's the ODN knowledge. Okay. We have the ODN knowledge. And thus we understand inside this PAN, the optical PAN technologies, we have the concept of the T count, right? We have the GEM port, how they transmit the packet. We understand we understand the OLT and the OLU, the function to convert the Ethernet packet, right? They convert the Ethernet packet. and the GTC packet, they convert it. All right, yeah. And then we have the IP address knowledge. We have the IP. So in the IP, the last week we introduced the VLAN. We use the VLAN. So in the VLAN, we understand the tag. We understand the tag, right? Yeah. So the tag is mentioned the 3 times of the port, right? Access, and the trunk. And then we have the hybrid and the hybrid. And the hybrid we seldom use. Usually we use it in some camera connecting. Okay. So this we learned that. We learned that. And today, it just the past hours, we learned the U10 protocol. The U10 protocol. Right. The U10 protocol. I introduced the typical WIP, the Written Information Protocol, and this one is based on the vendors, right? The how many let's hope it has. So this is so-called the vendor WIP. It's not so popular. Actually, it's not so popular. And the OSPF, the dynamic protocol. This one actually is little complex. But anyway, it's the popular. OSPF is the popular. Maybe the protocol itself is something like complex, but actually the configuration after we finish the configuration, actually is more helpful. It's more easy for us to make the maintenance. Something like the pump. When I introduce the pump, maybe many details in the TCON, in the GEM port, many details. But after that, actually, the configuration is not that complex. So actually, after this one, we get this knowledge. Actually, we are ready to go to the configuration. Actually, we are going to the configuration. But before we go to the configurations, I still wanted to introduce the Wi-Fi first. The Wi-Fi, actually, why? Why? Because the Wi-Fi we use every day. And for the configuration, it's not so configuration related to the, I mean, the configuration doesn't need many configuration for the Wi-Fi. Because the Wi-Fi is a setting, right? It's already setting in the ONU, right? We just use it. We are not so many configure for them. So before we go to the configuration for the internet service, for the VoIP, for the internet, right? Before that, I will introduce the Wi-Fi, and then we go to the configuration. Okay, let me see. Yeah. Okay, so here about the VLAN and the routing. For the switch, okay. For the switch, we understand in the switch we have a table. Okay, we have a table. We have a MAC table. Okay, MAC address, and the IP, and the port. In the interface, why? They are matching. So this one is in the switch. In the router, we also have a router table, right? In the router table, we don't have the MAC, okay, because the MAC is the layer 2. Okay, it's the layer 2. So in the router tables, we have IP address, right? We have IP address. We have also the interface, also have the port, right? And then we have the destination and the source. Okay, the source IP address range and the destination IP range, right? And then we have the less hot, So something like the less hot is exactly what does the routers mean, right? So this one, the table, switch table, router table. Yeah, so this one, so this is because when during the presentations, maybe yes, maybe we we get a lot of the detail, and then we fail to remember what we learned, right? Yeah. So this is the summarize. The summarize actually is helping us. It's helping us to understand what already get. Right? Yeah. Okay, so since this one, actually we can go to the configuration, but because the Wi-Fi is not much configuration, so before we go to the practice, let me introduce some Wi-Fi. Okay, let me introduce some Wi-Fi. Okay, so here we have two organization. The one is the IE. The last week I also introduced the organization relationships, right? Yeah, the IE actually is belong to the American, right? Yeah, our C data all follow these organizations standards. We all follow. But some big company, they are not follow. They think their company is big enough. They can create the standards by their own. So so sometimes when our C data products connect to another O1U, or our O1U connect another big company's ONT, sometimes it's fail. Sometimes it will fail. And after all the troubleshooting, the final result is they are not following the exactly standard. So this one, so this is also yeah, it makes some troubleshooting experience. Our C data follow all the standard. Also we follow the Wi-Fi standard, of course, right? Yeah. So sometimes we call is the Wi-Fi 4, Wi-Fi 5, Wi-Fi 6, and 7, right? Yeah. So this one is following the name from the Wi-Fi NS. And these two organizations, they work together. And then they issue the standard, IE standard. We see AO2.11, AO.211. The Wi-Fi actually beginning with Hawaii, because there's too many islands there. They want to communicate make the communication between the islands. So they made the Wi-Fi. So this is the original purpose. Yeah. Okay. Yeah. Because they work together, so sometimes the Wi-Fi has its own name, and then is the IE also has its own name. So for us, so we will maybe we prefer the Wi-Fi 7. We people to call this, okay? We people to call this, right? Yeah. Yeah. Do you remember when I introduced the our C data's ONT? So sometimes ONT we support we support the AX1 1500, and some ONT we call is AX 3000 series. So the AX is from here, okay? It's from the IE's name, right? It's from the IE's name. So for those number, actually, it doesn't have the meaning about this alphabet, okay? It's just the ghost name. In the IE, they have a groups to make the standard. So this one, so this is the group. So it have many small group, a small team. So they name the team one is A, team B, the second team we call is the B, something like this. So it's the team N. So maybe some group of the name. So the AX is also it's just also. Okay, yeah. Yeah, so AX, so how we come from the AX. So in here, we see from here, we have some detail. We have some detail. We have the channel, okay? We have the frequency, okay? This channel means the frequency. We have 80, so this one is 80 megahertz. And we see the Wi-Fi 4 at the beginning is 20 megahertz. And the Wi-Fi 3 is the 20 gigahertz. And then this is the frequency channel. And then we have QAM. So what does the QAMs mean? The comms actually is the Wi-Fi, the wireless transmission technology. How they send the signal, use this invisible way, right? Invisible way. How we can convert this one? Convert this one to 1 and 0, 0 and 1, right? So this will be so-called the QAM. Okay, one by one, you see. Okay, so here is some give us the overview first. Wi-Fi 4 is equal to the another name is 11N. Is 11N. Wi-Fi 5 is 11AC. Okay, 6 is AX. Okay, so when the C data products, right? C data products, we sell the AX, right? AX1. 1,000 and 1,500. It means the here we have two frequencies. We see two frequencies. One is the 2.4, another one is 5. So this frequency altogether we support the 1.5 gigabit speed bandwidth. So this one, in this case, we call it AS105, 1,500. And in another case, if the 2.4 gigahertz and the 5 gigahertz, they together can provide the 3 gigabits bandwidth, we call it AS3000. It's a 2. If you remember, when I introduced the ONT, the C data ONT, we have a 4 antenna, right? If you remember, we have 4 antenna. Two of them is provide the 2.4 frequency, gigahertz frequency. The middle one and 2 is provide the 5 gigahertz antenna. This one antenna. And we have a phone here, okay? Here we have a phone. So what is this line? This line, it means the antenna, okay? The antenna is inside the phone. If this phone has two antenna, so here one antenna connect to here, okay? And then we call this one is a channel, or we call this one is a tunnel. Channel or tunnel, it doesn't matter. It's the same meaning, okay? And then here also go to here, okay? And then I change another color. This antenna go to here. So totally, it has a 4 channel to transfer the signal, okay? To transfer the signal, okay? 4 channel, 4 channel. So so in this case, we call it a MIMO. Okay, because one antenna, it has a 2 channel, right? So yeah, so we so-called is a multi-in and the multi-out. This is technology, multi-in and the multi-out. So this one is only the 2.5, 2.4 gigahertz frequency, right? And so do the 5 gigahertz. You also have another 4 channel to transmit the signal. Okay, here. So totally we have 8, right? We have 8 channel. We have 8 channel to transmit the signal. Multi-in and multi-out, 8 channels. Okay. But unfortunately, some phone they only support you select the 2.4 gigahertz or you select the 5 gigahertz. So actually, usually, some phone it only support the 4 channels, right? It's like this. But if the phone support, I can connect the 2 frequencies at the same time. So you get the 8 channel. So if you get the 8 channels to transmit the packet, and then you get the high speed, right? Yeah. So this is the so this is behind the physical we see, and behind it, this is the knowledge. This is the technology. Okay. Yeah. So yeah. So it's interesting, right? Yeah, we see here we see the but the Wi-Fi 4 it only support the special stream is only the maximum is 4. The Wi-Fi 6, Wi-Fi 5, Wi-Fi 6, I support the maximum is 8. The 8 channels, 8 channels. Okay, so this is the channel. What does the channels mean? Frequency. So in the 2.4 gigahertz channel, actually it's a range. Actually it's a range from 2.400 gigahertz to 2.5. So we still have yeah, this one. Okay. After the dot, we have yeah, sub channels. So the scientists they separate those range to 40 sub channels, and each one is 20 megahertz. Okay, so sometimes in the old one, in the old time, in the old standard 11B, it was 22 megahertz for one channel for some channels bands. But after that, 11N, you see, 11N is the Wi-Fi 4, right? So actually, it's from the Wi-Fi 4. They use the 20 megahertz for one channel bands. Okay, this one. Okay, you remember this one. Okay, let me show you in the last, just the last slide. What is this? And then they have a graph. They have a graph. This graph is 5 megahertz. So they will not affect each other, right? Yeah. So here we have some groups. Go 6, go 11. They will not affect each other. The go one will affect from 2 to 5, right? Yeah. Yeah. So remember this group, okay? Remember this group. Remember this group. Here. Remember this group, this one, okay? Yeah, so we have 4 groups. They will not affect each other. So in one area, for example, I put the O1U here. So if this O1U, he select the channels 1, and then another O1U, he can automatically, okay, this one is auto. He can automatically select the channel 6. And this O1U it also can automatically change the channel 11. Okay. So in this case, we so-called this one is the Scheller system. Okay. It's funny, right? Finally, we know what is the Scheller, right? This is Scheller. Okay. So the amazing, so the technology amazing is the auto. Okay, it's auto selected. We don't need to select this one manually. Okay, yeah. So sometimes we set 20 megahertz, the bandwidth, the speed, the internet speed. The internet speed is slow. The internet speed is slow. So we can expand this frequency from 20 to 40 so that means from here to here. Okay, so from here to here we can expand it. So in this case, so if we affect the channel 6, so for example, the O1U from here, one O1U is from here. If we extend the 20 megahertz bandwidth to the frequency to 6, maybe if we affect this one, right? Maybe if we affect this area, yeah. So when we extend this frequency, maybe if we affect another O1U. Okay, just remind you, maybe affected here. Okay, now we understand what does this mean. In the O1U, website, we can set the Wi-Fi, and then we can select the 20 megahertz. We can select the 40 megahertz. By default, it's the 20 megahertz. And then you understand the channel. Okay, you understand the channel from 1 to 13. Actually, the 14 is the reserve. Actually. So let's see. Let's see. OLT. This one. Oh, because the device manager. This one is because my ONU is not online. I think. Anyway, I need to go to here. I have the CMS. Yeah, this is why the CMS is good, right? We support the cloud, the cloud CMS. It doesn't matter where I connect it. I still can find some ONU for use. Yeah, configurations. Okay. ONU manager online and configurations. Why I doesn't see the Wi-Fi's? So I think I need to find the ONU to bring it to here. Here is automatic maps. Yeah, Wi-Fi. Okay. Yeah. So here is the Wi-Fi. Okay. Yeah. Anyway, I don't need to wait the internet. Okay. So this one. We understand. Okay. We understand this parameters meaning, and here we see we have country region. What is this use? Why we set this parameter? Why we set this parameter? Because the country region is related to some technology. It means the it means the DFS. DFS. I think it's some of my friend is coming from the XNet, the company. It's coming from Mexico. Okay. It's coming from Mexico. So in Mexico, you have this dynamic frequency selection. It means this one is using from the radar. It's using from the radar. So who will use the radar? Military. Okay, the military will use the radar, and the airplane and the airport. Okay, it's not the only the military, but we also our people. Okay, our people commercial the airport. Okay, the airport will also use the radar, right? So those house, so those building near the airport, if they use the ONT, they use the Wi-Fi, and those ONT, the channel is the same is the DFS, is inside the DFS. Okay, so the radar will affect the ONT. So actually, this one is a really happen in Mexico. This one is a real case. It's a real case. Some of the customer, the end user, they complain. They complain the Wi-Fi is not working normally. It's not working normally. Sometimes it's working. Sometimes it just stopped. And then we made the deep analyze, invested, and then we find this ONT. It's near the airport, and the channel. I don't know why. I don't know why this ONT it just let the channel automatically receive this we so-called the DFS. This one is the radar range. The radar using also using the same channel. So this one it will affect the Wi-Fi, the ONT's Wi-Fi. This one is a real case. It's a real case. And this channel, we see in the 5 gigahertz range, actually we get more of the channels. Okay, yeah. In the 2.4 gigahertz, right? This one we have only 14 channels, but in the 5 gigahertz, actually we have a 165 channel. But for the commercial using, we are begin with the 36 because 1 to 35, the USA ministry is using. Okay, is for the US ministry. They are not allow us to use. So the commercial using is from 36 to 165, and part of them, and still part of them, is using from the radar. Is using from the radar, and some country like USA and Mexico, they are using the same channel for the radar. Okay, from the radar. And in China, maybe the radar channel is the different. So this is why. So this is why in the configuration we have a parameter to select the country. Okay, yeah, the different country the radar using is different. So this is why provide the country parameter here. Okay, yeah, yeah, interesting, right? Yeah, interesting. So since the 2.4 gigahertz, we can extend the bandwidth from 20 to 40. So to the 5 gigahertz, we also provide the 20 to 40. And even we can extend the channel to 80. And the maximum is 160 gigahertz. This one is the maximum. Okay, yeah. So when we go to the configuration, we see the maximum. We see the maximum is the 160 megahertz, the bandwidth. Okay, yeah. And then the channel. Okay, channel. We can from here. Okay, so maybe you so if you not attend this training, so maybe you confused where is the 1 to 35. Maybe our C data made the wrong products. No, okay. We made the correct the product. Okay, because 1 to 35 is the USA ministry using. Okay. Here's maybe another question, right? So why the USA define military using 1 to 35, and then will affect all over the world? It will affect all the world because the Wi-Fi standard is from IE. Okay, it's from IE, and IE is belong to USA. Okay, this is why. Okay, this is why the USA government, okay, sometimes it will affect the technology all over the world, okay, because the USA government, it can affect the IE organization. IE is belong to the USA, okay. It's not like the ITU, okay. It's not like the ITU. ITU is the union, right? It's the union countries, right? It's all over the world. And the Wi-Fi standard is from IE. Okay, even the Wi-Fi elements, right, is from Hawaii, right? Even the Wi-Fi is from Hawaii University. It's also belong to USA. Yeah, so this is why this is why sometimes the American government can affect all over the world, right? Yeah. So we missing. Okay. Anyway, we missing the 1 to 35 channels. Okay. We missing. So it's from here to here. Okay. And then here is the dynamic. This one dynamic frequency. This one is for the radar. Okay. From the radar using. Okay. From the radar using. We can avoid. We can manually avoid it, or we can automatically avoid it. Okay. Okay. So since we know the Wi-Fi is using the wave, right? We using the wave to transmit the signal. So in the technology, we say the higher sorry, this one is one, right? The higher electricity is the one, we represent one. The lower one, we represent is a zero, right? Yeah. So this one, again, is the mathematics graphic, science, science. This one is the science. This one is the cosine. Right? Yeah, back to the middle school. Yeah, back to the middle school. Yeah, this one is one. This one represent zero. Okay, this one one zero. Okay. Yeah, because the sine and the cosine, we can send it by two different rate together at the same time. At the same time, they will not affect each other, right? Yeah, in the same time they will not affect each other. Okay. Yeah. So in the technology, we can send them at the same time. At the same time. Oh, sorry. So at the same time, this one is the yeah, this one is the one one. Okay. This one zero zero. Okay. So for example, I just made the example. So from here, this one, for example, is the 1 second. Okay. So inside this 1 second, we can send you can send 1, 2, 3, 4, 5, 6, 8. We can send 8 bit. Okay, we can send 8 bit information. Do you remember at the first day, the first hour, I asked him, sorry, G Pang. I asked him the question, G Pang is a gigabit or gigabyte? Why I asked this question? And most of us understand it's a gigabit, and some of us the answer is a gigabyte. So here is the answer. Why? Why this one we are using the bit? Because in the communication technology, we are using the bit. Okay, we calculate based on the bit. So in this case, for example, yeah. So for example, this one we can control the way, we can control the way, right? We can control the way. So this one we represent it this way. We represent is a 0 0. Okay, and this way the shape we represent this one. Okay, we represent this one. So this one we so call is counter trace activity modulation. So this one I represented is 4 times 4 quant 4 quant. Okay, yeah, 4 quant. Okay, so 4 quant it means the one trace represent the 4 bit. Okay, 4 bit. Yeah, so the yeah for 4 quant is 4 bit. Okay, in the future we say it's the 16 quant, right? So it represented at the same time it represents 6 bit, right? Yeah. So let's see. So I have an IPv4 address. Okay, I have my IPv4 address, and this one is 192.168. Okay, 168, 101, and dot one. Okay, so this one convert to the binary. Convert to the binary is 1100 and o. Okay, this one. And 169, 168 is convert to the binary is this one. Okay. 101 is a one. Let me see. Okay, this one is because I calculate before. It's not I so strong for the mathematics. It's because I calculate before. Okay, yeah. Okay, yeah. So if we using the 4 quant, So for example, this one is the let me see. 1100 is where? 1100 is where? Is here. Okay. 1100 is here. Okay. So this one I need 1 second. Okay, because 1 second 1 second 4 bit, right? Another second, this one. Okay. Another second. Okay. Yeah. So in this IP address, okay, for again this one, okay, this one 1010. Where's 1010? Here, okay, 1010 is here. So I need 8 seconds, right? Totally, I need 8 seconds to represent this IPv4. Of course, in the real time, it doesn't need 8 seconds. Okay, I just made the example. Okay, 8 time slot. Okay, I need 8 time slot to transmit this IPv4. So it's not so faster, right? It's not so faster. It's not so faster. So this is why the scientists now they developer 60 core. In the Wi-Fi 4, actually, is they are using the it's already used the 64 core. So one time slot, they can transmit 64-bit information. This one. So in the Wi-Fi 7, in the Wi-Fi 7, in the quantum technology, they can one time slot, they can transfer 4K quantum. This one is so-called the 4K quantum as many. Okay. So this is why. The frequency they're still the within this frequency. Okay. They still using the 2.4 gigahertz and the 5 gigahertz frequency. But in the Wi-Fi 5, they can transport, they can have the higher bandwidth. It's because the quantum technology, the quantum technology. And what does quantum technology? So this is what I'm saying. Okay, they control the wave, and then they can transmit more. Sorry, maybe few more minutes. And this is the memo already introduced. Okay. This is also I already introduced AX1 1500 and AX 3000. Okay, this one because the bandwidth together with the 2.5 gigahertz and 5 gigahertz, this bandwidth they plus all together, and then we supply the 1.5 gigabit. And this one AX3000 is a 2.4, and this one they all together they provide the 3 gigabits. So this is where's the name come from? Okay, here is the dBi, the analog. So usually the dBi is higher, and then they can transfer longer. But the range here we missing some. If the phone is exactly under here, and then he cannot get the signal. But usually in the real time, in the real situation, if you not like that, actually we still can get some signal. Okay. Okay. Yeah. So in the in the home. We usually will put, we can see, usually we will select, this is the worm, right? This is the worm. So usually we will put the ONT in the middle, or in the middle higher. Okay, and then he can send the signal. Okay. Okay, yeah, this one is the signal. Sorry. Yeah, this one is a. And because we are using the Wi-Fi, so in this case, we can use the mesh because if you're not using the Wi-Fi, we are using the mesh. We need to connect many cable. It's not easy, right? But with the Wi-Fi, we don't use the cable. So this the Wi-Fi technology provide the mesh implement is easy. Easy. The mesh means we can use one single network name and the password, and then they can transmit. It's a -seconds mesh. So here's the mesh. This is the products our C data can provide the mesh. Okay, so finally the Wi-Fi protects. So we have a WPA3. This one is the latest. Wi-Fi 3 is the latest. This one. Okay. At the beginning, it's the WEP, the Wi-Fi Protect Access. And now wired WEP, it means the wire equips private. This one is the earliest one. Now it's using this one. Okay, using this one. And the AEC, product, we are the technology we support the 128. This one. Okay. This one is the okay. This one I will not say that. It's just the it's just about the password, how to protect it, right? We need the password. In the WPA, we have a private, and we have an enterprise. Maybe sometimes you will face this concept. For the personal, for the family using, usually we use the WPA personal. It doesn't mean it's weaker. It doesn't mean this one is weak. It means that we don't need a radius. Because if we use the WPA enterprise, we need radius for the AAA. Okay, for the AAA authentications, right? Authentication, right? And accounting. So this one, why? So in the WPA, WPA enterprise, this one, AX1, 1X, we need the radius server. And for the family use, we will not use the radius, right? We don't need. So maybe sometimes you will face this concept. So this is the difference. After training, you can read the detail. Okay, you can read the detail. So in here, so now we understand. What is this parameters meaning. Okay, in the O1U, go to the O1U, we select the Wi-Fi, and then we select the authentication. What does this mean? It means the technology, how to protect the Wi-Fi, how to protect the SSI. Okay, so this is all for today. And tomorrow's we will go to the configuration, the web and the CLI. Okay, tomorrow I will go to the OLT, CLI, and the web configuration for the internet. Okay. Yes. Okay, thank you. Thank you is gracias, right? Spanish, yeah. Gracias. Okay. Okay, so see you tomorrow, my friend. See you tomorrow. Yes. Yes. Gracias. Okay, see you. Okay. Yeah, good night, good evening. Yeah, good dinner, all right? Yeah, good dinner.